Hi everyone, my name is Dr. Ismail Msangi, a lecturer in material science and physical chemistry from the United Republic of Tanzania. In front of you once again to proceed with the discussion on topic overview on material science. And the last time we ended with discussion on classification of alloys based on composition. And today my lesson will focus more on classification of alloys based on atom arrangements, where we are going to discuss substitution and interstitial alloys, and also classification based on phases, where we are briefly going to see homogeneous and heterogeneous alloys. Starting with substitution and the interstitial alloys, these are classes of alloys depending on the atom's arrangement in a crystal lattice. That when we mix metals, more than metals together, we expect two different kinds of mechanism to happen depending on the size of the atoms. We expect either atoms may mix in atom exchange mechanism, or atoms may mix through interstitial mechanisms. And through all these two mechanisms, size of the element in the mix plays a primary role to determine which mechanism will occur over which mechanism. So, when the size of the mixed atoms differ much, that one of the atom are bigger compared to the rest, we expect atom exchange mechanism to dominate or to happen over the interstitial mechanism. And this is because when sizes of the atoms are similar, it is easier for one atom to replace the other without much affecting the structure of the material. So when atoms are similar in size, we expect the atom exchange mechanism to happen, where some of the atoms will be replaced or substituted by other constituents of the mixture. And the resulting alloy formed when atoms are exchanging one another is what refers as substitutional alloy. And a good example of this kind of alloy is bronze, where copper atoms are replaced by tin. And as we know, copper and tin have almost similar size. They are not same per se, but the sizes are not having much difference. So it is possible for tin to replace copper without much effect on the structure of the resulting submaterials. So if it happens like that, then the formed material will be referred as substitution alloy, where tin will replace copper and form a mixture of material called the substitution alloy. But in other scenario where mixed atoms differ much in size, it becomes difficult for smaller atoms to replace the bigger atoms. So what happens is that the smaller atoms will successively trapped into spaces between the bigger atoms. And scientifically, the spaces which are formed between the bigger atoms are called the interstices. So instead of the small atoms replacing the bigger ones, they become trapped in the spaces between the bigger ones and form a mixture of materials which is called the interstitial alloys. And here is an example of interstitial alloy where carbon atoms are mixed with iron, and as a result of difference in atomic size, carbon may not replace iron in the mixture. Instead, carbon atoms become um, trapped in between of iron atoms and form interstitial alloys. And this is one of the best example of interstitial alloy where carbon is trapped between the iron atoms to form steel, which is a very good example of interstitial alloy. Sometimes, apart from having atom exchange or interstitial mechanism, it may happen in some scenario that the two mechanisms may happen at the same time. That some of the atom will be exchanged, but at the same time, the smaller atom becomes trapped at the interstices of the other atoms. And as a result, the material formed will have combination of scenarios where some of the material will be replaced by some will be trapped at the matrix. And a good example of this situation is the formation of stainless steel, where some of iron atoms are replaced by nickel and carbon atoms are trapped at the interstices of the matrix. So in general, the formed substance will have more than two kinds of atoms. For example, in this stainless steel, the material will compose of iron, and some of the iron will be replaced by nickel or chromium, and also the carbon atoms will be trapped at the matrix of iron and nickel or chromium. These are more illustrations on substitution and interstitial alloy, where this is another good example of substitution alloy, where copper atoms are replaced by zinc atoms, which are presented with gray color, to form an alloy which is called the brass. And here we have another example of interstitial alloy where carbon atoms are trapped at the matrix, at the interstices of iron matrix. Apart from atom arrangement, alloys may also be classified depending on phases, where we have alloys having single phase and the alloy having more than one phases. And the phases in reference to this kind of classification refers to uniformity in components distribution. That when material is having components evenly distributed throughout, then the material is referring to have a single phase and it is referred as homogeneous alloys. But when material is having components which are not evenly distributed, where some parts of the material will having more concentration of a certain component and the other parts of the material will have more concentration of the other components, that will be referred as multiple phases, where the alloy will be regarded as heterogeneous alloy. So, in homogeneous alloy, the components are generally distributed throughout the material, where each part of the material will have almost similar composition of the components, where in heterogeneous, the components are not evenly distributed throughout the material, and different components of the material will have different compositions of the components. And sometimes you may have mixture with more than two components, where the distribution of components may be even, and hence the material will be called the homogeneous, or the distribution of the components will be uneven, and hence the material will be referred as heterogeneous. Taking an example of this component here, you can see at the middle of these components, uh, the concentration of the components is different from the sides of this component. So the sides of the components makes different faces, and the middle part of the material will make another face, where the composition of the middle part will have different composition, and the composition of the other part will also have different composition, referring to the components making the materials. But when referring to this material at the right, you can see all the components, the yellow one, red one, the green ones, and the purple ones are at least distributed throughout the material, where we expect any portion of this material will have the same composition, and this material is regarded as homogeneous material. So this marks the end of today's session. The next session we will proceed with our discussion by focusing on properties of materials. Thank you for listening.